Welcome to the Titus Timeout Podcast. I'm Matthew McLaurin. In this episode, we'll be discussing particle migration and how to control or prevent it from happening. To begin, we need to understand what causes particle migration. For this, we'll consider two adjacent rooms with the same amount of particles present and a neutral pressure condition. In this case, there will be no significant movement of particles between rooms. However, if there is a pressure differential between the rooms, particles will migrate. In this case, the room on the right is positively pressurized. The particles will move to the room with the negative pressure condition. We can also have particle migration when there is a neutral pressure condition. This occurs when the particle count in one room is higher than the other. In this case, the spaces will eventually reach an equilibrium with the particle count being equal on each side. An example of this would be a fish tank with a partition and a small hole. If you pour a little coffee into one side, eventually the whole tank will end up with a uniform distribution of those few drops. There are two basic ways that we can control particle migration. The first is pressurization. Positive pressurization is used to prevent outside particles from migrating into a clean space. While negative pressurization is used to keep potentially harmful or dangerous particles from leaving the room outside of a controlled manner. The second way to control particle migration is clean air changes. By introducing clean air and exhausting room air, the particle counts are able to be controlled, preventing migration as a result in difference in concentration. In most cases, there is a combination of these two techniques being employed to control particle migration. The type of space and types of particles being controlled will determine the level that needs to be used for each room. Don't forget to subscribe to our YouTube channel, and thanks for taking the time out with us.